Welcome to the DIY Honda Garage channel. The DTC P219A indicates an issue relating to the air-fuel ratio variation of a cylinder in the Honda CR-V models from 2017 to 2022. This error specifically refers to a discrepancy between the expected and actual air-fuel mixture ratio. If this error code is triggered, it implies that one or more cylinders is not getting the appropriate amount of fuel or air needed for efficient combustion. Efficient combustion is crucial for optimal engine performance, fuel economy, and lower emissions. The air-fuel ratio is particularly monitored by the air-fuel ratio AF sensor, which helps to ensure that the engine is running under ideal conditions. It is essential to address this issue promptly to prevent further engine inefficiencies or damage. The DTC P219A relates to an air-fuel ratio issue that occurs in one or more cylinders of the Honda CR-V's engine. Specifically, the air-fuel ratio sensor plays a vital role in determining the correct mixture of air and fuel injected into the cylinder. This sensor is typically located in the exhaust system and monitors the gases exiting the engine to help adjust the fuel delivery for optimal combustion. A fault in the air-fuel ratio sensor could lead to improper fuel injection, which might subsequently cause performance issues. Monitoring this sensor's readings is crucial during diagnostics as it provides valuable data regarding the combustion process in the cylinders. Identifying any anomalies will assist in determining the root cause of the error code. There are several possible causes for the DTC P219A to trigger. Firstly, a faulty air-fuel ratio AF sensor is a common reason. This sensor may not accurately measure the air-fuel mixture. Next, an injector malfunction can also create discrepancies in the combustion process, leading to the error code. Each cylinder's injector is responsible for delivering precise amounts of fuel, and if one or more injectors are failing, it can disrupt the entire mixture. Additionally, engine compression issues are another potential cause. If one cylinder has lower compression than the others, it will not fire effectively, leading to performance problems. Thus, carefully inspecting each of these components is essential for accurate diagnostics. When experiencing DTC P219A, the driver may notice several symptoms that indicate engine performance issues. Poor engine performance is often prominent, with the vehicle struggling under acceleration or idling roughly. Furthermore, increased fuel consumption can occur due to inefficient combustion caused by an imbalance in the air-fuel mixture. As the vehicle attempts to rectify the mixture, it may consume more fuel than usual, leading to higher running costs. Another noticeable symptom would be the illumination of the check engine light on the dashboard. This warning light indicates that a fault has been detected by the vehicle's onboard diagnostics, prompting the need for a thorough inspection to determine the cause of the issue. The first step in troubleshooting DTC P219A involves verifying the problem using the Honda Diagnostic System, HDS. Begin by turning the vehicle to the on mode, which powers up the electronic systems without starting the engine. Once in this mode, it's crucial to record specific snapshot parameters from the HDS. These include vehicle speed, engine speed, the manifold absolute pressure (MAP) sensor reading, engine coolant temperature (ECT) sensor 1 data, accelerator pedal position (APP) sensor, and short-term fuel trim (AFFB). After documenting these parameters, start the engine and hold the engine speed at 3,000 RPM without load until the radiator fan activates. Then allow it to idle. Under these conditions, conduct the cylinder AF test 3 times in the HDS inspection menu, analyzing every result thoroughly to determine whether they fall within acceptable limits. In this step, the focus shifts to conducting an OBD status check via a test drive. Utilizing the previously recorded snapshot parameters, take the vehicle out for a drive, ensuring to replicate the condition shown in the onboard snapshot. It is essential to monitor the parameters meticulously while driving to capture any deviations accurately. After the drive, access the OBD status for DTC P219A within the HDS. If the HDS indicates a failed status, it confirms that the failure has been duplicated under the observed conditions, allowing you to proceed with further diagnostics. Conversely, if the HDS reports passed, it signifies that the system appears to be functioning well at that moment. In such cases, attempts should be made to reproduce the failure using the freeze data recorded during the initial incident. The third troubleshooting step is an engine compression check. First, turn the vehicle to the off or lock mode to ensure safety while working on the engine. A cylinder compression test is then conducted across all cylinders to evaluate their performance. This test gauges whether any cylinder exhibits lower compression than the others. Lower compression can indicate several internal issues, such as worn piston rings, faulty valves, or head gasket failures. If the compression test reveals that one cylinder has inferior compression, it's critical to repair the underlying engine compression problems before proceeding. Conversely, if compression levels are consistent across all cylinders, it will lead you to the next step in the troubleshooting process. Step 4 in the troubleshooting process focuses on checking valve clearance. This step is vital because improper valve clearance can lead to performance issues in the engine, including problems with combustion that may trigger the P219A code. To perform this check, the vehicle should be turned to the off mode. Inspections should determine whether the valve clearance falls within specified parameters. The clearance settings are crucial for the engine's optimal performance. If the clearance is found to be within acceptable limits, this suggests that valve issues are not contributing to the DTC. If not, it would be essential to adjust the valve clearance before proceeding to the next diagnostic step. In this step, the goal is to conduct another cylinder A5 test with the HDS. Begin by starting the engine, then maintain the engine speed at 3,000 RPM without load as before. This step is performed under controlled conditions, ideally with the AC off and all electrical loads deactivated. This controlled testing helps to eliminate external influences that might skew results. After maintaining these conditions, conduct the cylinder A5 test 3 times through the HDS inspection menu. If all results return as satisfactory, it may indicate an intermittent failure, which suggests that the vehicle may be functioning adequately at this time. However, if the test fails, further diagnostics will be required, moving to the next step to pinpoint the issue accurately. The 6th troubleshooting step involves checking the fuel injectors to ensure they are functioning correctly. Begin this step by turning the vehicle to the off or lock mode before exchanging the injector from the problematic cylinder with one from another cylinder that is known to be functioning properly. This injector swap allows for a direct comparison to see if the problem resides in the injector itself. After swapping, restart the engine and hold it at 3,000 RPM without load, just as in previous tests, ensuring the AC and other electrical loads are off. Once again, perform the cylinder AF test 3 times. If the results indicate an injector failure in the cylinder that received the swapped injector, this would mean all injectors should be replaced as a set to ensure uniform performance across the cylinders. The final troubleshooting step necessitates a thorough visual check of the intake and exhaust manifold. During this inspection, the technician should look for any signs of carbon buildup, which can restrict airflow and affect the air-fuel mixture, leading to performance problems. carbon deposits can negatively influence the combustion process, exacerbating issues linked to DTC P219A. If any carbon buildup is detected, it is vital to check the engine for oil leaks, as these leaks can introduce additional carbon into the combustion chambers. Cleaning off carbon buildup and addressing any oil leaks is crucial for restoring optimal engine functionality. If no buildup is found, it may suggest an intermittent failure, and further checks for oil leaks should still be performed to ensure system integrity. In the final repair verification phase, it is crucial to confirm that all repairs made have resolved the issue effectively. Begin by rechecking the diagnostic trouble codes, DTCs, using the Honda Diagnostic System, HDS, to ensure that DTC P219A no longer appears. This check will provide insight into the success of the diagnosis and any subsequent repairs made. After verifying the absence of error codes, a test drive of the vehicle is recommended under various conditions to ensure that it operates ordinarily and there are no reoccurring issues. This process not only affirms the repair work, but also ensures that the vehicle performs efficiently and meets emission standards, highlighting the importance of thorough checks after repairs. Preventive maintenance is essential for the long-term health of the Honda CR-V engine and can help avoid issues like DTC P219A. Regular inspections of the air-fuel ratio sensor ensure early detection of potential failures before they become significant issues. Additionally, maintaining the fuel injectors and ensuring they are clean and functioning will help preserve proper fuel delivery to the cylinders, keeping the air-fuel ratio balanced. Checking for carbon deposits in the intake and exhaust systems should also be a part of routine maintenance, as early cleanup can prevent them from significantly impairing engine performance. By following these preventive measures, vehicle owners can maintain optimal engine efficiency, improve fuel economy, and reduce the likelihood of future DTC occurrences. In conclusion, the DTC P219A represents a critical issue concerning the air-fuel ratio variation of a cylinder, which can lead to diminished engine performance and efficiency if not addressed promptly. This diagnostic trouble code can result from various issues, including faulty sensors, injector malfunctions, and compression problems. It's vital to perform thorough troubleshooting to identify and correct the root cause of the error. Intermittent failures may sometimes complicate diagnostics. Hence, keeping a detailed record of symptoms and conditions is beneficial. Regular maintenance of the vehicle's fuel system and engine components is essential to preventing such issues moving forward, ensuring that all critical aspects of engine operation remain optimal and that performance standards are met. Please like and subscribe to the channel. See you next time!